First thing you need to do, you just log in with your credentials. This will be the same email and password you set when you make an account on our website, and I'll send all that information along in an email once we've had our demo meeting. Before the big update that we just shipped, the tool used to work exclusively using all these buttons up here. As you can see, there's a lot of them, so this new version has a much clearer workflow that's somewhat similar to Helioscope, so should be pretty intuitive. I'm going to open it up here and add our project specs. We'll call it St. Benedict. We'll add the zip code 56374. Enter ground mount, so we'll leave that and hit OK. So that'll kick off a fresh project for us with the project name and zip code. So first thing we're going to do is we're going to define an electrical zone, which allows you to group modules and assign them each specific inverters and panel types. Looks like you guys are just using the one inverter and the 630 watt Jinko module. So let's add a zone. We'll call it field. We'll assign all these panels here, and it'll automatically extract all 2200 panels out of these blocks. Yep, 2200 panels. That looks good. Now we're going to run this string sizer, which is, may not have heard of it before. It's a cloud-based tool developed by Lawrence Berkeley National Lab called PV Tools to find the most optimal string length per the project code, the location, the minimum temperature, the project hardware, etc. I'll include a link to it in the email so you guys can check it out yourselves. But so in the string sizer, you can load your saved configurations. You can see your previous runs. I've got a ton here from all my tests, but it auto-populates our zip code. Then we'll use our Jinko 630 modules, and you can, of course, add your own panels if they're not in our database already, or you can edit any existing hardware, either ones that are already in there or ones that you make. Then we'll add our TerraMax 330K SolarEdge inverter. You can see it automatically detected that we need the H1300 optimizer. So then we'll just specify a few more things that the string sizer needs. Our panels are monofacial. We've got a single axis tracker. Let's use the standard open rack glass polymer thermal model. Axis tilt of 0 degrees. Let's say it's an azimuth of 90 degrees. Let's use the default ground cover ratio, and let's say a max angle of tilt of 90 degrees to enable backtracking. Okay, so we'll send that off to PV Tools, and there we go. Very quickly returns our results. We've got our optimizer summarized up here, our power summarized here, and that power is based on the string length that we've got here. There's a lot of stuff, a lot of information in here to dive into, so I'm just going to reduce our inverter count to 3 to bring our DC to AC ratio up to 1.41 and skip forward for time's sake. Now the electrical zone has its hardware spec, calculated string length, and its DC to AC ratio. We can move on to grouping the panels. We call these panel groups because they're not quite subarrays. They're groups of panels that are grouped together in a way that will be compatible with our string lengths. So if we have uneven sections, we'll need to grab panels from other groups. All we have to do to group them is click this button here, and our groups will be created automatically. There we go, 28 in total. But you can see this message here says that 28 of 28 cannot be cleanly divided into string lengths of 46. We can see that in the label here it says infeasible with lengths of 46, and that's because we need to either add 17 or subtract 29 panels to fit 46, 45, or 44 length strings. So in the last version, you used to have to balance these all by clicking a group, selecting the panels you want to steal, and our users said that was way too time consuming. So we added this auto balance button that when we click just magically transacts the panels between the groups, and you can see this panel group claim these panels here, which made it possible to string with 2 45s. And it did that for all of our panel groups. So now we've created our panel groups. We know how long our strings are, so we can click this solve button and confirm that yes, we want to target a string length of 46. And just like that, we've got all of our strings. So if we zoom in here, you'll see that each string has a tag, and It's currently blank and grayed out, but that will change once it gets associated with the combiner box, which we'll add in a few steps. We've got the stats for the string summarized here, 49 strings made of 11 46s, 22 45s, and 16 44s. And now we just need to place our central inverters. You see we've got 3 here to place. Looks like our interconnection point might be from this building here, so we'll drop them in this corner. We'll assign a number, so that's 1, there's 2, and there's 3. And you can see they've all been added to the summary table here, so now we'll move on to the next step and add our combiner boxes. So 2 things will happen this step. First, our combiner boxes will be automatically located in the lanes and positioned and assigned strings such that the home runs lengths are minimized to those strings. And then the combiner boxes will get their own runs back to the central inverters. So we'll click this button. We'll get to choose the size of our combiner boxes. Right now, you can only choose one size for them, but for all of them. But in a future iteration, we'll be able to size them all individually. We've just got the one combiner box that needs 9 strings. So, but right now we'll just choose 12 for all of them. So our combiner box fills all 8 inputs besides one with 9, and our combiner boxes were placed in here at the ends of the arrays in the lane, and you can see that all of our strings are now colored and labeled accordingly to the combiner box they're associated with. So, and then we've got these pink runs from our combiner boxes back to our central inverters. So the last thing to do is add our home runs from our string endpoints to our combiner boxes to get our circuit lengths. Again, we can just do that automatically by clicking this button, and there we go. All of our home runs are added. Engineers that we've talked to, they used to draw all these home runs by hand and then go one by one like this using the properties palette to manually extract the length from the calculator, drop it into Excel, run it through, some sort of cable sizer, and do this hundreds of times. So that is now a thing of the past, because right here in this next step, we can just click this cable export cable schedule button, and instantly we get this table summarizing all of our circuits as both positive and negative home run lengths, the string length itself, their combined length, and then our one-way circuit length for cable sizing. And you can export that to Excel or into an AutoCAD schedule, and I've left one of those exported schedules in the drawing for you guys to check out. So that's it for now. We've got so much more functionality, even just right here on this cable export form. So many more tabs I'd love to run through with you guys. But not only for ground mounts, but we've also got some cool stuff for rooftops specifically, some analysis tools, some SolarEdge Web Designer PDF imports, if you guys ever use that web app designer. We've got an MPPT, an inverter balancing tool, so much more to take a look at. So take a look at the drawing. Let me know what's broken, wrong, incorrect, needs to be shown differently, whatever. And put all those thoughts together for us to cover in a call, hopefully sometime soon. Alrighty, thanks. Talk soon.